June 1942, near Gazala, Libya. Under the scorching sun of the North African desert, officers of the 21st Panzer Division, part of Rommel's vaunted Afrika Corps, gathered around a strange trophy of war. It was unlike any tank they had ever seen. It was tall and looming, its silhouette awkward and angular, its hull held together by rivets instead of welds, and its weapons configuration seemed to be an irrational compromise. A small 37mm cannon sat in a high turret, while its main armament, a 75mm gun, was fixed in a sponson on the side of the hull with an extremely limited traverse. To the German soldiers, accustomed to the rational and efficient designs of their Panzer IIIs and Panzer IVs, this machine looked like a relic from a bygone war. The tank, an American-made M3 Grant used by the British Army, had been abandoned nearly intact after a fierce engagement. Its sand-colored paint was still fresh, and the markings of the British 1st Armored Division were still clearly visible. The German officers smirked. "Sieben Särge für sieben Brüder," one muttered. 7 coffins for 7 brothers, a morbid nickname alluding to its large crew. They saw it as proof that American industry, though massive, was still naive in the art of modern warfare design. They could not have been more wrong. This lone M3 Grant, towed from the battlefield and later pressed into service for transport to Germany, would initiate a painful reevaluation within the German Army Ordnance Office, Heereswaffenamt. It would force Germany's most brilliant engineers to confront an uncomfortable truth. The war would not be decided by superior tank design on paper, but by an entirely different industrial philosophy, one that prioritized mass production, mechanical reliability, and ease of maintenance over technical perfection. This ugly, clumsy M3 was not a design flaw. It was the opening salvo from an industrial giant, and the lessons the Germans would learn from it would foreshadow the much greater shocks they would face when they later encountered the M4 Sherman. The journey to Kummersdorf, the first alarming signs. The order came down from the highest level. This American tank was to be brought back to Germany for a full inspection. It was assigned a temporary number, and a German crew was tasked with driving it hundreds of kilometers across the desert to the port of Tobruk for shipment. This was its first real-world test, and the results began to sow the first seeds of doubt. German panzer crews were accustomed to frequent stops. Their Maybach engines, while powerful, were temperamental in the desert sand and heat. Air filters clogged constantly. Overheating was a persistent problem, and final drives often failed under the strain of continuous movement over harsh terrain. A 100-kilometer road march without a mechanical breakdown was considered a success. The M3 Grant, with its Reich R975 Whirlwind air-cooled radial engine, a design originally intended for aircraft, behaved in a completely different manner. The German crew, initially skeptical, drove the tank over dusty tracks and soft sand. The engine roared with a steady, powerful rhythm. The temperature gauge remained safely in the green even under the midday sun. The transmission, while not as sophisticated as Germany's, was robust and predictable. There were no alarming grinding sounds, no sudden oil leaks, no need for constant stops to tighten bolts or check components. After 2 days' journey, the Grant arrived in Tobruk without a single serious mechanical failure. The accompanying mechanics, who had come prepared for major repairs, only had to perform basic maintenance, cleaning the air filters and checking the oil levels. The contrast with their own panzers was stark. A Panzer IV making the same journey would likely have needed a few road wheels replaced, its cooling system flushed, and possibly transmission work. This American tank, which they had mocked, simply worked. News of its strange durability was sent back to Berlin even before the ship carrying it left port. At Kummersdorf, Germany's top-secret weapons proving ground, engineers began their preparations with a mixture of curiosity and disbelief. Kummersdorf, autumn 1942. Dissecting the clumsy giant. When the M3 Grant rolled off the flat car at Kummersdorf, it immediately became the center of attention. Engineers, ballistics experts, and armor strategists swarmed around it, notebooks and cameras ready. Its external appearance confirmed their initial prejudices. Silhouette and armor? It was far too tall, presenting a large and vulnerable target on the battlefield. The armor was riveted, a technique Germany had long since abandoned in favor of welding. Rivets were in theory a critical weakness. When struck by a shell, they could shear off and fly around inside the fighting compartment like bullets, causing casualties even if the armor itself wasn't penetrated. The armor plates were mounted vertically instead of sloped, reducing their effective protection. A design from the 1920s, one senior engineer remarked. Armament. The weapons layout was deemed a tactical disaster. The 75mm gun in the side sponson had an extremely limited horizontal traverse. To engage a target outside that narrow arc, the entire tank had to turn, a slow process that exposed its weaker side armor. The 37mm turret on top was too weak to engage medium tanks and was primarily useful only against light armored vehicles and infantry. 2 additional machine guns seemed superfluous and complicated the crew's duties. Crew compartment. Inside, it was surprisingly spacious compared to the cramped confines of a German tank, but the layout seemed chaotic. The 7 crew members, commander, 37mm gunner, 37mm loader, driver, 75mm gunner, 75mm loader, and radio operator machine gunner, appeared to get in each other's way. The initial inspection seemed to confirm every stereotype. The Americans could mass produce, but they didn't know how to design an effective tank. However, as the technical teams began to dismantle the tank piece by piece, a different story began to emerge. A story of priorities, design philosophy, and industrial capacity that the Germans had completely underestimated. Discovering the core, the engine, driving, and the good enough philosophy. The focus of the analysis shifted from the external appearance to the internal mechanics, and it was here that grudging admiration began to replace contempt.
1. The Wright R975 Whirlwind engine, a reliable aviation heart. The German engine specialists were astonished when they identified the M3's power plant. It was a 9-cylinder, air-cooled radial engine originally designed for aircraft in the late 1920s. To the German mindset, using an airplane engine in a tank was a stopgap measure, an admission of the lack of a proper, dedicated tank engine. German engines, like the Maybach HL-120, were liquid-cooled V12s. Compact, high-performance power plants designed specifically for armored vehicles. However, as they examined the Wright engine, they realized its practical advantages. Proven reliability. This engine had been produced by the tens of thousands and had demonstrated incredible durability in civil and military aviation. It was not a new, unproven design. It was a workhorse. Air cooling. In the desert, an air-cooled system completely eliminated problems associated with radiators, hoses, pumps, and coolant, all components vulnerable to damage from sand, shrapnel, or simple vibration. While it was bulkier and required massive airflow, it was fundamentally simpler and more robust. The German engineers noted that the M3's cooling system was far less likely to be disabled by minor combat damage than the complex liquid cooling system of a Panzer. Ease of maintenance. Accessing the cylinders and spark plugs on the radial engine for basic maintenance was relatively easy. The entire engine block could be removed and replaced as a single unit at field workshops, a far quicker process than performing a major overhaul on a complex V12 inside a cramped hull. An internal report began to circulate. While theoretically suboptimal for a tank application, the selection of an air-cooled radial engine represents a remarkably pragmatic solution, prioritizing operational reliability and mass producibility over peak performance. It reflects an industry capable of leveraging existing production lines rather than creating entirely new and untested designs. 2. The transmission and suspension, simplicity as the ultimate strength. If the engine was a surprise, the drivetrain and suspension were a revelation. The M3's transmission was a rugged, unremarkable 5-speed forward, 1-speed reverse design. It lacked the sophistication of German semi-automatic gearboxes, but it also lacked their complexity and fragility. It was a transmission that any truck mechanic in America could understand and fix. The gears were large, robust, and built with generous tolerances, allowing it to withstand abuse from inexperienced drivers, a stark contrast to German transmissions that required highly trained drivers to avoid stripping the precisely machined gears. But it was the Vertical Volute Spring Suspension that truly gave the German engineers pause. The German suspension system, typically the torsion bar system on the Panzer III and later designs, was technically superior. It provided a smoother ride and better cross-country performance. However, it was a maintenance nightmare. If an inner torsion bar broke, mechanics had to disassemble a huge portion of the suspension, including the outer road wheels, just to access it. It was a job that took hours, sometimes days, in a fully equipped workshop. The American VVSS was the complete opposite. Each unit of 2 road wheels was attached to an independent bogie with its own spring. If a bogie was damaged by a mine or simply wore out, the entire assembly could be unbolted by removing a few large bolts and replaced with a new one in under an hour, right on the battlefield with basic tools. A Kummersdorf report articulated the philosophical difference. The American suspension design clearly prioritizes speed of field repair over maximum performance. While our system offers superior mobility, it demands factory-level repair facilities for serious damage. The American system accepts a slightly lower performance threshold in exchange for the ability to return a damaged tank to the fight in a matter of hours, not weeks. Strategically, this advantage cannot be overstated. The reevaluation, when flaws became features. Slowly, the bigger picture began to emerge. What had first looked like a collection of clumsy design mistakes now looked like a series of deliberate decisions, driven by a ruthless and practical logic. Why rivets? Because in 1940 to 41, American industry had immense capacity for riveting. Locomotive works, shipyards, structural steel fabrication, but lacked the facilities and skilled labor to weld thick armor plate on a massive scale. Using rivets allowed them to start producing thousands of tanks immediately, rather than waiting months or years to build new factories. It was a trade-off between technical perfection and immediate availability. Why the tall silhouette and strange gun layout? Because the M3 was a stopgap design. After the fall of France in 1940, the U.S. Army realized it needed a tank with a 75mm gun as soon as possible. They did not yet have a turret design that could accommodate such a large weapon. Instead of delaying production for a year or more to design a new turret, they chose a proven solution, mounting the main gun in the hull. This allowed them to get a powerful 75mm cannon onto the battlefield in 1942 instead of 1943. It wasn't ideal, but it was available. The tank's height was an unavoidable consequence of its tall radial aircraft engine and the stacking of the 37mm turret on top of it. Why the mechanical simplicity? Because America was preparing for a global war fought by a citizen army. Its tanks had to be operated, maintained, and repaired by quickly trained soldiers who had been farmers, salesmen, and factory workers. The systems had to be robust, understandable, and forgiving. The KISS, keep it simple stupid, philosophy was applied not out of a lack of engineering prowess, but as a conscious strategic decision. The German engineers began to realize that they had been judging the tank by their own criteria, technical optimization and the tactical performance of an individual vehicle. But the Americans were designing to an entirely different set of criteria: speed of production, strategic reliability, and logistical sustainability. They weren't trying to build the best tank in the world. They were trying to build a tank that was good enough to win the war and to produce it in numbers Germany could never hope to match.
Direct comparison M3 Grant versus Panzer III and IV. As firing and mobility tests were conducted, the comparison with the M3's contemporaries, the Panzer III and Panzer IV, early to mid-war variants, further highlighted these findings. Firepower. The Grant's 75mm M2/M3 gun, despite its limited traverse, was an excellent multi-purpose weapon. It could fire a far more effective high-explosive HE round than the short-barreled 75mm on the early Panzer IV, making it a superb infantry support and anti-AT gun weapon. More importantly, its armor-piercing AP round could penetrate the frontal armor of any Panzer III or IV at typical combat ranges in 1942. In contrast, the Panzer III's 50mm gun struggled against the M3's frontal armor. While its configuration was flawed, the Grant's main firepower was superior to its adversaries at the time. Reliability. Test data and field reports confirmed the initial observations. The operational readiness rates of British M3 Grant units in North Africa, despite supply chain issues, were consistently higher than those of German panzer divisions. German tanks were constantly out of action due to mechanical failures. A panzer division with 150 tanks on paper would be lucky to have 70 to 80 operational on any given day. A Grant was simply more likely to make it to the battle than a panzer. Survivability. While the riveted armor and tall profile were disadvantages, the M3 had its merits. Its roomy interior meant that if the armor was penetrated, the crew had more space to avoid shrapnel and escape hatches. It was also less prone to catching fire than early gasoline-powered German tanks. The conclusion of the German analysts was unsettling. While the Panzer III and IV were tactically superior designs with their 360-degree rotating turrets, the M3 Grant was a strategically more effective war machine. It carried a more powerful gun, was mechanically more reliable, was easier to repair, and was being produced at a rate of thousands per month by factories like American Locomotive, Baldwin Locomotive, and Chrysler, companies that hadn't even built tanks a few years prior. Echoes from the Eastern Front. The Soviet perspective. The Germans' concerns weren't just based on their own tests. Through intelligence, they knew the M3, the Lee version with a slightly larger turret, was being sent to the Soviet Union under the Lend-Lease program. Initially, the Germans saw this as a sign of Allied desperation, sending second-grade equipment to a struggling ally. But reports from the Eastern Front told a more complex story. Soviet tankers had a love-hate relationship with the M3 Lee. They nicknamed it BM7, Bratskaya Mogila na Semerich, which meant a grave for 7 brothers because of its tall profile and large crew. They hated the gun configuration and the riveted armor. However, they also praised it for the same reasons the German engineers had discovered. They valued the reliability of its engine and drivetrain compared to their own early designs. They loved the 75mm gun, which packed a much bigger punch than their 76.2mm on their T-34s at the time, especially when firing HE rounds. The spacious interior and high-quality optics were also appreciated. Even when obsolete, M3 Lees took part in major engagements like the Battle of Kursk in 1943, often employed as self-propelled guns from defensive positions. The fact that the Soviets, with their immense experience in armored warfare, continued to use the M3 showed that the tank had practical virtues that went far beyond its obvious theoretical flaws. The silent acknowledgement and lessons not learned. The reports from Kummersdorf and the intelligence from the fronts painted a clear picture for the German high command. The American threat was not one of technical sophistication, but of production capacity and a brutally pragmatic design philosophy.
The M3 was the first proof that America could turn its immense industrial potential into real military power at an alarming rate. And yet Germany's engineering culture was so deeply ingrained that they were unable or unwilling to fully learn this lesson. Instead of emulating the American philosophy of good enough in great numbers, they went in the opposite direction. Faced with mounting Allied numbers, they doubled down on technical quality. Their answer to the M3, and later the thousands of Shermans, was not a more producible and reliable tank. Their answer was the Tiger and the Panther. The Tiger I, an engineering marvel, nearly invulnerable from the front and armed with the legendary 88mm gun. But it was also incredibly complex, resource-intensive, slow to produce, and a logistical nightmare. It required its own unique spare parts, special fuel, and dedicated maintenance teams. The Panther. Designed as a direct answer to the T-34, the Panther had excellent sloped armor and a high-velocity, long-barreled 75mm gun. But it was rushed into production. Early models were plagued with catastrophic mechanical problems, especially with the transmission and final drives, which were under-engineered for its 45-ton weight. At the Battle of Kursk, more Panthers were lost to breakdown than to enemy action. Germany built better individual tanks than the M3 or the Sherman, but they lost the war of reliability and production. For every one Tiger built, America produced hundreds of Shermans. And more importantly, while a Tiger battalion might have only 30 to 40% of its tanks operational due to maintenance, a Sherman battalion routinely maintained readiness rates above 80 to 90%. The legacy of the clumsy giant, a lesson in industrial warfare. The M3 Lee Grant had only a brief moment on the front lines. By mid-1943, it had been largely replaced by the far superior M4 Sherman in the Western theaters. But its role in the war was far more significant than its combat record. For the German engineers at Kummersdorf, analyzing the captured M3 Grant was an eye-opening and deeply unsettling experience. It shattered the illusion that German technical superiority was unchallengeable. It gave them their first glimpse of the true power of the arsenal of democracy, not just the ability to produce in vast numbers, but the ability to design war machines that were good enough, simple enough, and reliable enough to be kept running by a citizen army on battlefields thousands of miles from home. They saw that the Americans were solving a different problem. While Germany was trying to build a perfect saber, America was mass-producing brutally effective hammers. And in a total war of attrition, the hammer always wins. Years after the war, when West German engineers began designing the Leopard 1 tank, the lessons from Kummersdorf still echoed. The Leopard 1 was not the most heavily armored or powerfully armed tank of its time. Instead, it was designed with an emphasis on mobility, reliability, and maintainability, the very traits that had made American tanks so successful. In an ironic twist of history, the same engineering culture that had once scoffed at the ugly M3 Grant had absorbed its core lessons to create one of the most successful tank designs of the Cold War era. The story of the captured M3 Grant is not just about a machine. It is the story of a clash between two industrial philosophies, and it proves that in modern warfare, the tank that makes it to the battle and keeps fighting is always more valuable than the technically perfect tank sitting broken down in a workshop miles behind the front lines. It was a costly lesson the Germans began to learn under the blinding sun of the Libyan desert when they first laid eyes on America's clumsy but relentlessly tenacious iron monster.